Good afternoon, everyone. This is Bob Celeste from the Center for Supply Chain Studies, and this is Open Mic Friday. We have quite a list of folks that we'll be talking to today. If you've been on our site, I'll just bring that down for those that are looking at us, watching through the web. If you're on our site and if you'd like to review our previous Open Mic Fridays, if you just go to our site, go to Open Mic Friday, and we list both the previous Open Mic Fridays, the recordings for those, so you can look at those, and the ones that we're having now and coming up in the next few weeks. If you have questions, so we like to keep this kind of loose with the audience. If you have questions, you could do one of two things. Either press the raise the hand, and I'll interject into the unmute you and get you into the conversation. If you have a question you'd like to type and kind of tee that up, do that also, and I'll either do my best impression of you to read it to our guests, or I'll unmute you and you can ask the question directly. So why don't we get started with our call today? We're closing into almost a year on our study for the blockchain for cold chain study. And we initiated this study because of two other studies that were going on. Both of those being the Drug Supply Chain Security Act and blockchain. And the thought was, if we can trace a drug back to the manufacturer or the repackager, can we also pull forward more interesting or other interesting information, such as the temperature profile of the product as it's moved through the supply chain, so cold chain areas. And as you'll hear in our discussions, we got into more not just cold chain and temperature. We got into some other discussions about other sensor kind of readings that could be had as an item is tracked through the supply chain. What I'd like to do is just introduce our guests today. And so we've got a number of guests from the cold chain study. We have Mohamed Abado from Temptime Corp. Kevin Kapach will be in. I believe he's on his way in. He said he'd be a little late for the call, but he'll come in from Geisinger. Jeff Glazer, who's a consultant to HHS, and John Howells from John Howells Consulting. Matthew Liontel. Matt, I have you on. I've taken you off mute so you can join the discussion. Dr. Swami Narasimhan, who last week, if you remember, Dr. Swami was on talking about AI and machine learning, and that'll have a lot of, we've had some discussion on that also within this group. So we'll get a second shot at Dr. Swami. Ted Prizik from Temptime also, and Jim Sabago from T-Systems. So gentlemen, welcome to the show today.
Thanks, Bob.
Thank you.
Happy to be on, Bob.
There we go. I just want to bring up this graphic just to talk a little bit about the study and what we've worked through. So if you've been part of any of the center's studies, we do use simulations to simulate supply chain and information flow. In this case, we also simulated the behavior of different temperature collection points, whether those are from IoT devices, from indicators, from temperature controlled environments. And we added that into the simulation in order to learn about the cold chain supply chain, how information is captured, and how we might use technology such as blockchain to secure all of that and make that more available when needed. And so we talked about quite a few different scenarios that we might go through and how that technology could work. And so we've talked about the cold chain itself. We've talked about in the study blockchain, IoT devices. We also talk about packaging and its contribution. and also about analytics. And that's the kind of discussion we'll have today. And again, if you have questions as we go through, raise your hand on the panel or ask or type in a question, and we'll bring that into the discussion. What I'd like to start out with is let's just talk about some of the issues in cold chain. And Jeff's been really helpful in our study in bringing forward the real life look and the issues that are being experienced in cold chain, especially with the different modes of transport and different kinds of products that we've been talking about. So Jeff, I thought maybe you could just start out with a little bit about some of the things we've talked about around issues that we've encountered in moving cold chain products.
Sure. I think the right now, the tracking and tracing of the temperature controlled products is really based around the shipper and their responsibility in placing a temperature monitor tag onto the product itself. And as it goes through the supply chain at its touch points, the temperature monitor is shut off, recorded, and deemed satisfactory or unsatisfactory. And then a communication starts outside of the supply chain if it's unsatisfactory. So what we're faced with now is that there's not a contiguous flow of information with regard to temperature monitoring from the manufacturer on through to the patient. It's all in different subsets. And I think what we have a chance to do with, perhaps through blockchain and certainly through the Internet of Things, is to tie together that information, which is not being done now in a contiguous way, and perhaps find a solution as we conform to the Drug Chain Supply Security Act. So that really gives an overview of it and the challenges associated with aligning temperature and perhaps other indicators such as vibration, shock, altitude, pressure that may impact sensitive products along with the blockchain information and tie it together in one similar type of piece of data, not so much that the pieces of information are independent, but that they are at least uniformly put together. And I think that's what we're really facing now.
So is that one of the issues around, as if we look at the lifespan of a product as it moves through the supply chain and the different actors that would be handling the product, the data itself, is there being able to either connect that data or put it all together is one of the issues, the data itself, and it's maybe what I would say is non-standard format, maybe?
Yes, I think all of the above there, that there are different formats, different methodologies of tracking that information for the material, and how that information is gathered and maintained at each individual stop along the supply chain, knowing that the product may be put into a cold vault or a freezer vault while it's being held and then moved on to the next node of the supply chain. So it's difficult to kind of piece this together in what we have structured today, and it's completely reliant on everybody adhering to good manufacturing practices, and that includes transporters.
So I'm just gonna pick on a few people, if you don't mind. So Jim, when we initially started this study, we were looking at blockchain, and the reason I think we were looking at it was as a connector to these different delivery paths, let's say, or different hops that something would make through the supply chain. Can you speak a little bit to that and it's maybe the attractiveness of something like blockchain?
Sure. So this is Jim Salvago from T-Systems. One of the things that has drawn our interest, and the reason we're focused primarily on the Internet of Things, and everybody may be aware of this, over 50% of the new drugs that were released, that were approved by the FDA last year, require some kind of temperature control. Added to that, we do have the issue of diversions, counterfeit products, and things like that, more from a physical aspects of the shipment. Now, when you intersect, as shown in the Venn diagram, the IoT sensor data, and later on we'll talk about analytics, but when you look at it from a blockchain perspective, is there a way for us to physically identify if one of thousands of shipments basically falls off the rail? It didn't meet the temperature requirements, or somebody decided to put a forklift through one of the packaging containers, or, heaven forbid, the product is stolen. Then you use IoT devices to kind of provide that physicalness, if you want to think of it. And the data that's generated by it would be, obviously, it could be stored in a blockchain, or at a minimum, can provide an indication that all of these shipments went across, 95% of them went through okay through the supply chain, but there's a handful of them that require some additional information. And as Jeff pointed out, a lot of the data a lot of the practices that we've been going through really rely on the shipper to ensure that from the box to destination, from point A to point B, that it arrives at the right temperature. Sometimes, not always, but sometimes that doesn't happen. And so the IoT devices that T-Systems has brought to the market does a lot in terms of using GPS and GSM, think of your cell phones, if you will, especially if you lose your cell phone, where the heck is it? That's exactly what we're doing on these shipments. We can identify a product anywhere in the world, 170 countries, plus the fact that you can get temperature and shock and tilt and pressure and all sorts of things. You can start to build, if you will, the data around the condition of that particular shipment. And that information needs to be processed through analytics, and an indication provided in the blockchain would tell me that specific box, which could be one of multiple in a overall shipment, may be defective or red, if you will. Okay.
So maybe I'll ask Swami to come in, because last week we were talking about AI, machine learning, and so what we're starting to see here and in our study is a lot of data points that are becoming available through IoT and through a number of different avenues. And at some level, and it's certainly when we started to run our simulations, we produced a lot of data, and we couldn't make much out of it because it was data at that point. So in order to understand these data points and what they are actually mean, so Jim was pointing out, the different things that could be indicated from an IoT standpoint. Is that an avenue where AI or machine learning could help us out with understanding what's going on versus just seeing a lot of the data coming at us?
Yeah, definitely. This is Swami from CalcuLogic. Definitely, Bob. I think AI, particularly machine learning for sure, can play a major role. And the way it could is, imagine if you're seeing the sensor data for a period of time. A lot depends, of course, on how much information people know about the things they are shipping and how they behave. There may be different properties that these things have, so you can imagine, for instance, a drug that with a single excursion from its temperature limit, it may be a problem. There may be some for which the excursion has to be in place for a period of time before the drug no longer can be used, or the food can no longer be used. Or it could be the magnitude of the excursion, multiple excursions within a length of time, and so forth. There are so many different properties that these things could have. And so you can imagine that just getting all those implemented would require some level of data analytics and machine learning. And then, so you might say, right, you can imagine a mechanism that says you characterize which drugs can be classified as problematic given certain properties, and then let the machine learning algorithm essentially kind of start looking at the data as it comes through and picking the ones that could be suspicious or problematic based on these characteristics. So I do see a lot of potential for using of advanced data, because every time you have a huge big data stream like this, you need some automatic processing that combines the biology and the properties of the underlying good that you're shipping or whatever with the data analytics mechanism. So kind of generic math and statistics and machine learning algorithms have to be combined with domain data, but there's a lot of scope for it. And if you do enough of this, you might at some point have a predictive way to do this. So you could go that this drug went through the following things, but the 100 previous times that it went through when we tested it, it was actually okay. And so you might be able to predict that those types of things based on what you see in the past.
There's some interesting electronic advances that have been going on in capturing information right now. L-Pro, for instance, has come out with an electronic device that's comparatively inexpensive, that has a 4-year battery life and can actually be, and is small enough, about 1 inch by 1 inch by 1/8, it can actually be put on a package itself and read via Bluetooth cell phone, and that information could be loaded up into an integrated system via IoT. There are other companies as well, Berlinger and Temptime and Sensitech, who are working on more sophisticated electronics for just this purpose. So it really adds to the potential of capturing this data in a wireless way.
And we were sorry, once again, this is Swami. So that's a very valid point. I mean, I think the more data you have, the more visibility you have, the more smart things you can do, but it also increases the volume of data that you have to handle and so forth.
So a couple of the discussions that we've had in our group is as we looked at the product moving from one hop to another, I think it was generally said that we're on a pretty good track for understanding the temperature experience of a product as it moved between two points. But as we started to push a little bit further, because we're trying to tie this to the Drug Supply Chain Security Act and tying back many hops, I mean, and we've had a lot of discussions around feasibility around this, but being able to connect and see the temperature profile of a product in all of those areas in order to assess whether the product, how much of excursion or near excursions it may have had, maybe 2 or 3 times. Can we just talk a little bit about the sort of the data silos that we're looking at here, and whether it's feasible to be able to connect all that, and whether blockchain actually makes any kind of sense as far as being a part of this whole technology stack, if you will.
Hey Bob, this is Jim from T-Systems. I think there's a lot of business benefits in trying to capture the data. I think as Jeff mentioned, there are multiple ways to do this. Okay, and just because we have a sensor, Temptime has certainly some options. I think the audience needs to understand that there is business benefit with getting some of these things. And as much as you would want to monitor the condition of the shipment, it also gives you additional insight into the shippers themselves. Some of our clients have multiple shippers. They just don't pick one dispenser, for example, or maybe one organization to manage all the shipments. So when you have a bit of competition where maybe this information isn't available, you now have another means of trying to drive value for the organization in terms of monitoring what those shippers are doing for your products. That's just one business benefit. I'm sure there's probably others.
Interesting. Mo, I just want to ask you a question. As we went through this, we talked about temperature-controlled environments and being able to report that kind of information, and some of those may be hardwired. We talked about sensors, and then we talked about indicators. And initially, we were talking about how to connect an indicator to this data stream, if you will. And the initial conversations we had were around, that would be almost a human intervention, or maybe there could be a camera that looked at an indicator. Can you talk a little bit about indicator technology and how we're trying to move to better connecting that to this data stream?
This is Mo. Yeah, thanks, Bob. I think it's a good idea to get back to the basics a little bit. And actually, I would like to just go back even to Jeff's statement at the very beginning when he said there aren't really ways to connect a product from the manufacturer all the way to the point of use. But actually, with the chemical indicators, and historically speaking, at least from Temtime's perspective, we've been doing that for over 20 years now. So just as an example, our vaccine vial monitor, which is a simple chemical indicator label. It's very small. It goes onto a vaccine vial. It is applied at the point of manufacture and stays on the vaccine vial all the way until it's actually delivered directly to the children all over the world. So basically, it has been throughout the entire supply chain connected to the product at the point of use. I think the difficulty has been really taking that visual chemical indicator and, back to your point, connecting it somehow to the digital world, or how do we basically digitize that data and make it accessible and facilitate that information and have it accessible to everyone throughout the entire supply chain. And that's where, at least on our end, Temtime has been working on the method of basically embedding that temperature indicator directly onto a barcode. These days, basically with all these standards out there, it's pretty much a very common to have a barcode at every product level. I mean, at the unit, at the pallet, at whatever level you want. And typically, the barcode not only will it hold information like a batch number or the national drug code, or the batch number, the serial number, the expiration date, but we can also embed a temperature monitor. And basically, by scanning that barcode, you get all of that information, and you get, in addition to this, the temperature exposure. And again, all of that from the point of manufacture all the way to the point of use. And so every single time you scan, you get data points that you can upload directly to a blockchain and then disseminate and analyze, again, as Jeff was saying, after you get all of that data.
Mm-hmm. So some of our simulations we ran were, I would say, belts and suspenders, kind of let's light everything up. And so we had simulations where not only was all of the environments reporting their temperatures, and also we were simulating checking in and checking out of product into those environments so that we knew what was where when. We also, in certain simulations, we had indicators on every vial, if you will, and then we also had sensors in the packs. And so maybe we could talk a little bit about that. They kind of, I don't know, a lot of information coming out from all that, being, maybe not the totally feasible simulation, but we were doing that just to see what kind of information could be had ultimately, and then when that information was available. So as Jim was pointing out about sensors that are able to direct connect, and you can follow something as it's moving, and then as you get closer to starting to unpack, you start looking at the other data that's available through the indicators and things like that. So maybe we could talk a little bit about that kind of scenario where there's a dearth of information and many different levels of information as the product itself is being packed and unpacked and repacked as it moves through the supply chain. Or did I just spill out everything that that we saw in those models?
Well, this is Jim from T-Systems. I think what's important and the takeaway for the audience is that there's no shortage of options. As Jeff points out, as Mo points out, each what we're trying to do here is leverage, if you will, technology where it's immutable. Okay, so for every shipment, what I don't want is someone, and this happens in Europe. This is not something in the U.S., but it happens in Europe. A shipment gets stolen, someone copies the serial numbers, and then they introduce it into the supply chain. That's a weakness of the EU's ability to kind of manage their own drug supply chain. Here in the U.S., we don't really have that kind of a situation. So really, what you're thinking about is there for my business, is there a means of preventing counterfeits, making sure things have the right temperature and those sorts of things? And again, it's a very small amount. You balance that against the cost of your products. It may make a lot of sense to use Temptime. Absolutely. It's the simplest way to do things, so that when the patient gets it, if it's green, I use it. If it's red, I don't use it. Pretty simple. Whereas there may be other complicated products, right? Some with very low temperature requirements, and every degree minimizes the shelf life of the product. And as Swami described in the analytics, that's really, a way of kind of monitoring where your products are. So Bob, I don't know if that was answering your question, but certainly we've got a lot of choices, and from a DSA perspective, from the Drug Supply Chain Security Act perspective, DSCSA, I always have a problem with that. You're trying to leverage the technology so that that data becomes unchangeable, if you will. So, Bo, you agree from your side, or Jeff from your aspects?
Is it a lot like peeling the onion on data?
It is a little bit. The Temptime solution can be a very good one when applied, of course, in the sense that it shows the degradate of the product through the period of expiry date, not necessarily data-driven, other than saying that it's positive or negative. That doesn't necessarily mean it doesn't have validity. It absolutely has validity to it. Although a number of countries have not gone into that, it is a WHO standard, and that's very important. But I think what we're trying to do is capture something that is somewhat unique by product. The stability, sorry about that, announcements here.
That's okay.
The stability profile for each drug is generally unique. It's not standardized. Although the storage temperatures tend to be standardized, the potential excursions may be very different, and consequently the material may be perfectly satisfactory or not satisfactory, depending on the level of excursion. So these are some sensitivities, especially with expensive product, that need to be evaluated. So it makes it's not quite one size fits all in that sense.
Hi, this is Ted from Temptime. I agree completely with Jeff. I mean, there's not just one solution for every particular problem. The indicator that goes on in the beginning and stays all the way to the end has certain advantages. But if the organization who's monitoring is data-driven and wants to know what time and when and what temperature things have happened, obviously you need some kind of electronic device that's going to monitor those kinds of requirements. So, you've got compliance issues, particularly once you start talking about drug degradation in the United States. Companies, manufacturers don't like to share a lot about their stability data. And so I think mainly from the regulatory point of view, they're looking for compliance. Have you stayed within the limits for the amount of times that the manufacturer allows. Whether or not you, the shipper, knows those allowances is another story. So again, it's one thing doesn't solve every problem. I think in Temptime's case, we like to see indicators on in the beginning and follow it all the way through, so that there is that continuity of information with respect to temperature from beginning to end. Everything in the middle certainly is needed, but for the ultimate user, whether it's a pediatrician, whether it's a clinician, whether it's you at home, if you get a medication at home, you have that certain advantage of an indicator that follows all the way through.
Yeah, this is Swami. That's a good point, Ted. I think Temptime has this. The devices you were talking about before with the chemicals have that advantage. I think going back to Jim's point, there are definitely business use cases where even with a device like that, where the end user gets to determine, yes, this is a green and I can use it. As a person who's shipping the product to these end users, I might want to know that certain paths through the supply chain ended up with more red than green. And so I might make some choices about how to get the product to the end users based on analytics at a higher level, at aggregate level, to know I shipped 1 million products and 100,000 through this chain and 200,000 through a different chain, and kind of see how the statistics stack up so that I can make some smart decisions about which way I want to ship the products, because you can begin to see those characteristics. If you see patterns, you can take advantage of them. That's kind of the way I see it. So I think you always want the end user in charge of it if you can, in terms of fit for use.
And I think we're seeing just the level of sensitivities and information that companies, carriers would desire or have potential to desire in their supply chains. And that's why there are a number of solutions out there that can solve, from everything right on a vial and the label of a vial on through to full pallet quantities. And this really is, it makes it a little bit tougher, because if you have finite information on the full pallet quantity that's shipped, say, to a wholesaler, and then they break it down further, that information all of a sudden splits out into the market packages that are distributed from there.
Good. We have Peter Ebert is on the line. He's got his hand up. He wants to ask a question. Peter?
Yeah, thank you. I wanted to, Peter Ebert, Good Work. I wanted to bring in some blockchain dimensions and also a timeliness dimension. We heard about a use case where a medication that doesn't reach its end user, so it comes in red, means the death of this patient, because they needed that medication within 12 hours. And if it's delivered and you can't get a replacement in, that patient will die. And so there are some of these use cases that are really, from a timely perspective, important. And if you see this early on in the process, let's say when this is loaded onto the private jet that brings this piece of medication to the patient, and you already see it there, then you can react and get a replacement there in time. But then you also, from a liability perspective, if you backtrack and you find cases like that, then you want to make sure that you can actually prove across a very diverse supply chain. To stay with this example, there is a manufacturer involved, there's the distributor involved, there is a private jet involved, there are maybe some carriers involved, and all of them are subcontractors. And so you have very different ways of tracking and logging who did what when, and in the end you have a damage. And so that's where I think blockchain comes in, as long as it's interoperable in the sense that you can then trust it across these various parties to make sure that you understand when did this failure happen, who is responsible, but then also, as Swami said, to start seeing patterns. So for example, if you have means to detect that a specific private jet always has these things, or a specific route through a specific region results into a particular failure rate, then you can start getting much more elasticity in your supply chains, transparency, and that saves cost.
One of the things that came up on our call, which I thought was interesting, and from a different, maybe you can kind of talk to this, was it's kind of a side benefit, was because at DSCSA we're able to trace back an item back through the supply chains, and we also are able to associate that item to its packaging. But we talked about sensors and indicators as also having almost I guess I would say, brand protection security aspect to them, besides just trying to report the temperature profile of something, that there may be some other things that you can do with the data to understand whether the product is in danger from other things, such other nefarious activities.
This is Mo from Temtime. I think this is a very good point, Bob. So, for example, when it comes to indicators and when you're talking about chemistry, I think it's, and in particular, yes, the cumulative chemistry, it is something that is not very easily to duplicate. I mean, you might be able to copy certain information at different points of the supply chain, but it's very tough to copy chemistry and try to generate it again and then put it on at different times of the chain. So I think this is a very good point that you bring, and that's one thing that the basics with the chemistry and the chemical indicators that should be kept at the back of everybody's mind. I think it's a very good way to deter anti-counterfeiters.
So Mo, can I just ask you, so if you have a chemical indicator and it has a certain color or hue, I don't know what the right word is, at printing or at manufacturing, let's say, do you have sort of a projections on what that should look like at various times, and able to tell if somebody's trying to either change it, in other words, put something else there, if they've let's say the product was stolen and it's gone out of range and they've tried to readdress the color on a product?
Absolutely. The chemistry is very well known, follows a scientific kinetics, exactly, thank you. And we can easily project these colors or hues, again, whichever term you want to use, and these actually even chemistries could be tailored to different product degradation profiles. So down the supply chain, if the color is not at a particular place where it should be, or if it goes back, or if it doesn't change at all, you'll certainly know that there has been some sort of alteration to it.
Interesting. So you may have recorded a certain degradation when you ship the product from the time you actually put it onto the product, and you have an idea of where that degradation will go, and if suddenly it seems to have reversed itself, that might be an indicator that there's an investigation should be had.
Correct. And again, the chemistry is not a chemistry that could be copied easily.
Mm-hmm. And Jim, just to follow up with some of the IoT things, we have discussions about understanding where the product is, and if it's gone outside of certain boundaries, that may be issues or something to look into. But having that constant feed gives you the early warning that something may be going on that you hopefully would be able to correct for.
Correct, Bob. A lot of our early use cases and a lot of the clients that we currently have now worry a lot about diversion. We've done a lot of work in the clinical trial space as well, where we're delivering products directly to patients in hospitals. So again, it largely depends on, you look at your technology that you need based on the products that you have, and then you look at it from that perspective.
Okay, I have someone.
This is Mo, and maybe just to add to Jim's last comment, another key factor is how much you really would like to pay at the end of the day, because some solutions are going to be way more expensive than other solutions, and if you are going to consider things at a unit level at the end of the day, that might exponentially increase the price.
That's a great point, Mo. Absolutely, and we see that when we do our proof use cases. There is that cost-benefit ratio we talked about earlier in this call. Mm-hmm. Agreed.
And John, I just want to bring you in for a second because some of our simulations are very optimistic, if you will. We tracked when something went in and out of a refrigerator unit, in and out of trucks, and all of that. How realistic and how difficult is that to do in a real live environment where you've got product that you're trying to get into, places to keep it cool, from your aspect?
Well, with the product itself, it's done on a daily basis, thousands of times a day, all across the nation in today's environment. I think what we have the opportunity for here is to not only maintain that current standard, but improve what everybody's talking about, the data here, and the ability to make decisions based on actual data versus getting a phone call from somebody, which is what happens nowadays when there's an excursion. Mm-hmm. So you can make much better decisions, have more confidence in the decisions, and also not disrupt maybe somebody getting a life-saving drug because you don't have confidence in that product and what little data you may have. So I think the supply chain does it very well on a daily basis. There are obviously bumps in the road here and there. We have had issues in the past, but as an overall supply chain within the U.S., we do it pretty well on a daily basis, thousands and hundreds of thousands of times a day.
So is this an area where, again, connecting this back to the DSCSA work of aggregating product into logistics units or containers, that those containers would be checked in and out of cold storage, if you will, and by doing that and having that aggregation data, we'd also be able to tell the story of the items inside of it?
I think that's one of the things we're doing through the modeling we're doing here, Bob, is trying to project out once we have a lot of the DSCSA in place, how can we leverage that process to get more value out of it and increase the efficiency and effectiveness of an already effective supply chain.
This is a good point. This is Jeff again. What we don't want to do is build a parallel system to existing transport documentation systems, which would be duplicative.
So maybe going back to Peter's point, maybe as we start to look at the DSCSA and tracking products and possibly using blockchains to provide that trust mechanism, that becomes the point that we can also make the connection between the cold chain world of temperature monitoring and other monitoring to the products itself. So today we may not know exactly what's inside the case that's being moved, but tomorrow, because of the DSCSA work, we'll be able to associate or I guess you'd say that the items inside inherit what's going on outside. So after we started to look at a lot of these optimistic, let's say, scenarios where we were collecting data from everything and everything was working inside the simulation, every truck that was running around was reporting temperatures, and we were able to look at that. We kind of looked at that as, we kind of took a step back and said, is this realistic? And we then kind of took an aspect of, let's just model for when something goes wrong. And so maybe we can talk a little bit about that and about excursion alerting and the kind of conversations we had around alerting, generally alerting around excursions and that kind of process.
Yeah, this is Swami. A couple of things. I mean, I think, for instance, right? Just let's look at the simplest thing. I mean, somebody, party A wants to ship something to party B in the supply chain. So in the normal, the event pattern, I would see the shipping event before I see the receiving event. So the shipping from A happens before the receiving event at B. But because of the way the real world works, and that let's just say charitably that the business process at A may be different from the business process at B, the receiving event from B may show up out of sequence with the shipping event from A, in the blockchain, or if that's how you're recording it, or even in a database. So the fact that you don't always see things in exactly the sequence that they happen and so forth causes a lot of grief in trying to do alerts, because am I supposed to immediately send an alert because the receiving event at B happened before, and so is that a counterfeit product, or should I wait a little while? And if you're putting this in a blockchain, then as soon as you receive it, if you put it in the blockchain, then somebody who's analyzing the blockchain will see things as anomalous, which they may not be. So I think the excursions and things like that, it's somewhat clearer how to do this in a perfect world, but in the real world I see a lot of problems where things arrive out of sequence, things, and making it very, very hard to analyze robustly. I mean, let me put it that way.
Mm-hmm.
And Bob, this is Jim. I learned early on, at least from when I was attending the calls and learning more about blockchain, there really isn't anything you see with blockchain. If you think about it, there's not really much going on other than we're generating hashtags, collecting data, and that kind of stuff. So the benefit of whatever kind of temperature sensing device you have, or some means of alerting those items that are in red or not fit for use, if you will, are the ones we really have to address. Because if you think about it, on the pharmacy or the hospital side, they get all these different packages that come in, and which ones should they set aside because they've been advised that analytics and the information associated with that shipment is out of spec. And really that adds to efficiency, that adds to, another business benefit. And hopefully it's not a product that's been tampered with. I think we sort of all assume that blockchain will prevent that, but there will be people that are going to try to pass fake stuff in here. So we want to be able to identify it, capture it somehow, and then alert the user.
So, and to follow on Jim's point there, I mean, DSCSA is actually intended to try to prevent illegitimate product from entering the legitimate supply chain. And I think with respect to the amount of data we're talking about being generated here, it's very important to note the industry today, everybody assumes everything's good as going through the supply chain unless something tips them off, especially in temperature sensitive products. So the importance of having that alert and having that information so you can make quick decisions whether the product's good or not good will help out the industry quite a bit as we move forward. We want to keep, I guess if I would use the term, the noise to a minimum, so it is legitimate alerts that are being sent out, not something because of, as Swami mentioned, something came in out of sequence, and therefore, and with respect to the temperature sensitive, it's a little easier because you're going to have some indicator that will tell you, hey, I've got an issue here, whether it's a full blown, I had an excursion where the product's no good, or it's something that needs to be evaluated, so I need to be following up with the manufacturer or something of that nature. It could go a couple different ways here.
So Jeff, early on, you sort of said something that was kind of interesting, that a lot of the alerts are false alerts because people forget to turn off the sensor, let's say. I just wonder if, as we start to look at sensors that are connected, whether from an analytics standpoint we can determine whether that might be the case, or do we really do have an alert?
That's a good question because it's somewhat unanswerable, other than the fact that somebody may have left a package out on the shelf when it should be in, or be refrigerated or frozen, or exposed to a higher temperature when it should be controlled room temperature. But I think that if the closer we get to a solution such as a microchip that's on each vaccine vial or each temperature controlled package that will have temperature, vibration, shock, humidity, light exposure, and have that all uploadable to a system would be very good. However, I think that that's a number of years off. Temptime has some excellent efforts on it, as do other manufacturers in different ways. But that would really make this discussion moot, and I hope that happens in the next 5 to 8 years or so, where it's cheap enough to put all of that information in one location and eliminate what I would call false excursions, where it was just accidentally mishandled or somebody interrupted the control of the material in a way that doesn't really affect the product. So I think we're moving towards that at a comparatively slow pace, not like other factors in the electronic industry, but I think we're going to have to take a look at that more closely as we close in on DSCSA timelines.
Hi, this is Ted again from Temptime. Just to pipe in on getting things, sensors down to micro scales. I mean, there are technologies out there, and we're talking with someone who does have sort of rice grain size sensors that are virtually, with just a little bit of light exposure, has enough battery life to last, repeatedly charged. The issue, though, is price. I mean, to get all that technology knocked down into a size that could fit onto a vial or a small carton is about there. But again, the cost starts to go up there, at least in current day. Maybe a decade from now it'll be a whole different story, and probably will be. But there are people working on real small sensors these days.
And just to add on to it, yeah, I'll add one other technology bit to that. This is Jim from T-Systems. Our sister division, T-Mobile, and you've heard of this in the industry from many of the cellular providers, 5G is due out next year, 2020, we'll have it on our cell phones, and that dramatically shrinks down a lot of these electronics because the battery size is dependent on how much energy you need to push the data through the internet. So once you have 5G in place, it's basically it's a one and done. So therefore the batteries start to shrink, everything starts to shrink. And we're starting to see sensors from today's cell phone size down to a quarter of that. And I think it'll just get, smaller and smaller as time goes on. Maybe not a decade from now. Maybe I would suggest maybe, 2 years, maybe even less. We've already got a device that we're testing now for narrowband, which is the 5G standard, already in test. So we know that technology is coming. Okay.
So that'll make that much of a difference.
It'll make that much of a difference. It'll get smaller for sure. Absolutely.
Jeff, you might get your sensor.
Yeah, I'd like nothing better than to see that at a price that is less than the price of the medicine. Sure. I'm exaggerating, but there you go.
So I'll just bring up a couple of other things that we had talked about, and if you'd like to chime in on any of those. We had talked about some other benefits like root cause analysis, and I think maybe this applies to what Swami was talking about. As this information becomes more available, it may be that we have an evolving picture of what's taking place with the product as it moves through. But certainly, when it's all said and done, being able to collect this data and assure that it's protected data and it hasn't been changed for that kind of analysis, so root cause analysis, risk-based intervention, those type of things. I was just wondering if you have any comments on those areas and those benefits in context of what we've been talking about.
Well, one reaction I have, this is Swami, is basically, as it relates to blockchain, I see it as really very good for, kind of its immutability, the fact that it has trust. But the very fact that it's immutable makes it much harder to do real-time type of stuff because, you often don't know whether the stuff on there is just taking its way, making its way through the blockchain to get there and so forth. So to answer your question, I think definitely there are opportunities to do this kind of stuff. But how you do it with a high degree of trust and with knowing that the parties that made the data available are certifying it, that's where the problem lies, I think, in finding the right architecture where the applications can have the data that they need and come up with reliable, trusted solutions in terms of data lineage and so forth.
Swami, does this tie into sort of you were talking about machine learning last week, that it may start to see patterns in how data comes in and may be able to anticipate that a little bit, like say, well, this one usually is a little bit late, so let's wait a little bit for it to happen?
Sure, of course. I mean, you might be able to say that, every time you went and kind of constantly alerted people, somebody earlier was making the point, I think it was John Howells, that you could have a lot of noise in which is clouding the signal, and the way that you might be able to get through that is to see, learn from what you had done before. So if I send 25 alerts to John and he says noise, noise, noise each time, that's feedback that I can use to go, well, maybe I should increase the time interval before I notify him about something in a eager fashion, so I'm not barking quite as much. The dog adjusting itself so it's not barking at the leaves, but waiting for a real thing to bark at. So it's like adjusting the false positive rate. Those types of mechanisms are available. It just comes down to, how reliable is the data and so forth. I mean, so such solutions exist. Generically in machine learning, these problems are solved. It's just, can we apply it in this particular domain? Is the data available, and is it of high enough quality to give you good results?
Mm-hmm. So should we add to our list of benefits here, alleviating alert fatigue, maybe?
I think so.
Okay.
Move them at this time.
Oh, Jeff, we're at the top of our hour.
One ticket, one seat.
And I just want to thank our guests for being on today. We will push the recording up to the website so you could get to it. We'll also put the contact information for our guests if you want to continue the conversation. Also within our area, if you've heard anything today that you'd like to have a deeper dive on, we'd be glad to kind of bring that story also to the forefront in a future Open Mic Friday or even a webinar. So thanks everyone for being on the call. I appreciate you being willing to kind of take these questions on the fly, and it shows the value that you brought to the study.
Thanks, Bob.
Thank you.
Thank you, Bob.
Thank you, Bob.
Thanks. Everybody have a great weekend.